Okay, now we have here 1.3 indices, sets, and logarithms. As for the learning outcomes, you have the first one. You should be able to express the rules of indices, explain the meaning of a set and its conjugate, and perform algebraic operations on sets. Okay, now we will look at the definition of indices. So basically, indices is a number a which is raised to a power n. So we have here a to the power of n, where a is called the base. And a here must be greater than 0, and a here is an element of natural number. So we have learned about the natural number. And n here is the index. N must be a positive integer. The index tells you how many times you have to multiply the number by itself. So that's the function of the index. So we have here, let's say, a to the power of n. It means that a times a times a times a, that is the n times. Okay, so now let's see what are the rules of indices. Okay, the first one we have, let's say you have a to the power of m multiply with a to the power of n. So this is equals to a to the power of m plus n. So for example, here we have 3 to the power of 5 multiply with 3 square. So what we will do here is that we have 3 to the power of, so we add the indices, we have here 5 plus 2 which is 7. So this is 3 to the power of 7. The second rule is that we have here a to the power of m divided by a to the power of n. So for the division, so we have here a to the power of m minus n. So we will subtract the indices. Okay, for example, here we have 2 to the power of 5 over 2 to the power of 3. So this is basically 2 to the power of 5 minus 3, which is 2 square, which is 4. Okay, the third one we have here a to the power of m to the power of n. So for this one, what we will do here is that we will multiply the indices. So we have a to the power of m times n. So for example, here you have 7 to the power of 2 to the power of 3. So this is basically 7 to the power of 2 times 3, which is 7 to the power of 6. Okay, the next one we have here a times b. So the base is multiplied together to the power of n. So for this one, we can split up the base to the respective index. So we have here a to the power of n times b to the power of n. So example, let's say here we have 6 square. So 6 here can be the product of 3 and 2. So we have here 3 times 2 square. So for this one, we can split up the index so that it becomes 3 square times 2 square. Okay, the last one we have here is that a over b. So the base is in fraction form to the power of n. So this is equals to a to the power of n over b to the power of n. It is basically quite similar to number 4, where we split up the index to the respective base. So for example, here we have 2 over 3 to to the power of 4. So this is basically is equals to 2 to the power of 4 over 3 to the power of 4. Okay. Now let's see what are the important things that we have to be careful when dealing with indices. Okay, so for the first one, we have, let's say you have a base to the power of 0. So this is basically is equals to 1. Okay, number 2, a to the power of negative n, so a is the base, is equals to 1 over a to the power of n. So that is for the negative index. Number 3, let's say you have a to the power of 1 over n. So you can see that your index here is in fraction form. So this is actually is equals to the nth root of a. And finally, number 4, let's say you have here a to the power of m over n. So this is basically is equals to a to the power of m. Then we take the nth root of the number. Okay, so I hope you understand about the important things that we have to be careful with when dealing with indices. Okay, now let's look at example number 1. By applying the rules of indices, so we will have to evaluate. So the first one we have 125 to the power of negative 2 over 3. So what we will do here is that we will apply the rules of indices, so that this one we will find something to the power of negative 2 over 3 where that something is power 3. Okay, why is that? Because we would like to multiply 3 with negative 2 over 3 so that we can cancel the 3 and the 3. So we will find a base that is when it is powered to 3, it will become 125. So this is 5 power 3. So for this one, we have here, when we multiply 3 with negative 2 over 3, we will have to cancel out the 3. So we will left with 5 to the power of negative 2. And this is basically 1 over 5 square, which makes 1 over 25. The second one we have here 1 over 81. 1 over 81 to the power of negative 2 over 3. So we will have here 81 to the power of negative 1 to the power of negative 3 over 2. So the index can be multiplied together so that we have 81 to the power of 3 over 2. Then we need a base to the power of 2 so that when we have 2 times 3 over 2, we will only left with 3. So the base that we need here is 9. So 9 square makes 81. So after the process, we left with 9 power 3, which is 729. Okay, the next one we have 1 over 25 to the power of negative 1 over 2. Okay, so the first thing to do is to convert the mixed number here to the improper fraction. So this is actually 36 over 25. Okay, you can see here that our index is negative number. So again, we will use the rule number 2 so that we have here 25 over 36 to the power of negative 1, again to the power of negative 1 over 2 from the original index. Okay, now the indices can be multiplied together. So we have 25 over 36 to the power of 1 over 2. Then again, we need a fraction to the power of 2, where we can cancel out 2 with 1 over 2. So we have to figure out something square which is 25. So that is 5 square. And another thing square which is 36. So that is 6 square. So we cancel out the 2 with the 2, then we left with 5 over 6. Let's look at example 2. We have here simplify. So we have to simplify the expressions given. We have here 32x to the power of 5, everything to the power of negative 2 over 5. So the first thing to do is to split up the base. So we have two types of base here. The first one is 32. The second one is x. So split up the base. So you have 32 to the power of negative 2 over 5. Multiply with x power 5 to the power of negative 2 over 5. So that is how you split up the base. Okay, what we have to do here is we will simplify the expression. So if possible, we will find a base to the power of 5 which makes 32, so that the 5 with the index negative 2 over 5 can be cancelled out. Okay, so we have here 2 to the power of 5 makes 32. Okay, so we can cancel 5 and 5. So we left with 2 to the power of negative 2. As for the x, we can cancel 5 and 5 straight away, and we have x to the power of negative 2. So this one, we have 2 to the power of negative 2, which is 1 over 2 square times 1 over x square. 2 square is 4, so this one we have 1 over 4 times 1 over x square. So we have here 1 over 4x square. Okay, the next one, we have here 3 to the power of n plus 2 times 9 power n over 27 power n. Okay, to simplify this, the first thing to do is we have to think about, is it possible to get all the base with the same value? So we have to figure out, can 9 be 3 to the power of something? Yes, of course. Can 27 be 3 to the power of something? Yes, again, of course. So we have here 3 to the power of n plus 2 multiply with, so 9 here, we will use base 3. Well, 3 square makes 9. So n here, we have to copy again. Okay, so divided by 27. So we have to find 3 to the power of something which makes 27. So 3 cubed is 27. So n here, please be careful with that. We still have the n. Now we will simplify the expression. So we have 3 to the power of n plus 2 multiply with 3 to the power of 2n divided by 3 to the power of 3n. So please notice that we have the multiplication and the division at the same time. So we have here 3 to the power of n plus 2. For the multiplication, we will plus the index, plus 2n over, so we have our denominator 3 to the power of 3n. So we have to simplify our numerator so that we have 3 to the power of 3n plus 2. As for the denominator, so here minus the index. So now simplify this, we have 3 over 2 which is 9. Okay, you can try on your own for C and D.